Hello, welcome. Let's try to solve another Leetcode problem today. 763 partition labels. So we are giving a string S. So as you can see, that's going to be a really long string. And we want to partition the string into as many parts as possible so that each letter appears in at most one part. Yeah, I think that even though it is a short description, but it's really difficult to understand. Yeah, we want to partition the string into as many parts as possible, so that each letter appears in at most one part. Yeah, so we need to use examples to try to understand what is the meaning. Yeah, if you understand the meaning, normally it's gonna be easy. Yeah, note that the partition is done so that after concatenating all the parts in order, the resultant string should be S. Yeah, so this means you can split it maybe from here, and we can put them together. Yeah, so this is just the meaning of this area. And we're gonna return an integer list. So we're gonna return a list like that. Now we should understand what is the meaning of the problem. Yeah. So we need to find some partitions. So for example, we can partition to A, at this position. So this means from here to here. So all the each letter appears. So each letter appears in at most one part. So for example, for letter A, it only appears in part 1. So this is a part 1. And from here to this E, so this is a part 2. Yeah, and this is a part 3. Yeah. So I mean for all the letters, it can only appear in one part. We just need to return an integer list, and it's gonna be the length of each part. Yeah. So we're gonna try to partition the string as many parts as possible. Yeah. So for this example, we can put it into 3 parts, and the length of each part is 9, 7, and 8. So if you can understand the problem like this, normally you can do it. But most of the people maybe not understand what is the meaning of the problem. Yeah. Now let's try to get a solution for it. Yeah. So for example, for the letter A. So for this letter A, we need to find what is the rightmost position for this letter A. It is here. Yeah. And then between this end letter A to here, we need to find another letter B, and we need to check if the position of the B, what is the rightmost position of B? It is here. So it is safe, it is okay. Yeah. Now we want to find another letter A, so it is in between. This B, it is also in between. And C, we can say C is also inside, it is here. Now, after all those checking, we find the furthest position is this A. So this is one part. So this is we can try to split as many as possible. So it can only from here. Now from the next letter D, we're gonna try to find what is the rightmost letter of D. It is here, E is here, F, E, and G. And all those letters only belong to the second part. And then from this H, we're gonna check, what is the furthest H to the right side. It is here, and then in between we can check I, it goes to here, and then in between we're gonna further check this Z, and here this Z goes to here, and all those letters are gonna belong to one part. Yeah, normally we didn't meet such kind of solution, such kind of idea, but this is just the greedy idea. The greedy idea is if we find a letter, we're gonna find the rightmost. Yeah, because in between it always meets the condition, and then we're gonna check some other letters. Maybe it is further, so we're gonna check it. Yeah, until we find the solution. So this is gonna be an O(n) time. Yeah. Now let's try to code it up like this. Let's check the letter. It is 500. Yeah, maybe it's not O(n) time, but later on, let's just analyze the time complexity. So first of all, we're gonna use a dictionary. I'm gonna use the default dict. I'm going to prepare a list for the dictionary. The value is going to be a list. Why? Because for this letter A, I want to find the rightmost position. So I want to put it inside the list. And later on, I'm going to optimize it. Now let's just put all the index with the character, in enumerate the string Yeah, so we're gonna put a dictionary like this. So cd dot append dc dot append I. Yeah, so it's gonna be, the structure gonna be like this. So we have a dictionary. So inside of the dictionary, for example, we have a letter A, and then we have a list. So inside the list, it may be the index like 0, 2, or maybe 8. I don't know. Yeah, because I just need to use this index, the last index is important for me. Yeah, and also for the letter B, maybe it is a 1, maybe it is a 9, it doesn't matter because I just need to have this 9. Yeah. So this is the first step. So the second step is that I'm gonna define some variables. Yeah, so I'm gonna define I equal to 0 for my first loop. So n should be equal to length of the string s. I also need to define another variable furthest. So this means the furthest position I can reach. So from the beginning, it's gonna be 0. Yeah. Now I'm gonna use a while loop to check. So while I less than n. Yeah. So from here, I want to calculate the furthest positions I can reach. So the furthest would be equal to the maximum of the furthest with the dictionary for this character. So it's gonna be the it's gonna be the si. So this gonna be a list. Si is my character, and the dsi gonna be a list, and I gonna choose the last position, for example, for the first A, and maybe it is B, and maybe others. Yeah, because basically I need to get the furthest position. Yeah. Now I need to define another variable z. Z gonna be equal to I. Yeah, because for distance. So for example, for distance, like from here to here, for in between this distance, I want to find if I can expand the distance or not. And finally, I need to put the answers inside my result array. Yeah. So I also need to define a result array. I just need to put the result inside it. Now I'm gonna use another loop. So while z less than n. Yeah, because z equals to I from the beginning. Yeah, so I will check if this z should less than not n. It's gonna be the furthest. Yeah, because currently I need to expand this distance. Maybe it is here. For the next time, maybe it is here. Maybe it is here. Yeah. So this position is the furthest. I need to use this furthest. Yeah, but definitely I don't need to use equal. I only need to use less. That is enough for me to calculate. Yeah. So while z less than the furthest, I can further on check the furthest. So the furthest would be the maximum of furthest, and with b as z minus 1. Yeah, I need to update it once more for the furthest position. And this z should plus equal to 1 because I want to check the next. Yeah, I'm gonna check one by one. Now from here, if I get the furthest finally, I can put it inside my result array. So the result array would be the furthest. Yeah, so it's gonna be the furthest minus I plus 1. Yeah, let's just try an example. So for example, from here, we are going to first check the character A from here, and I equal to 0 and I less than n, and we're gonna check the furthest, maybe here. Yeah, and then this z would equal to I. Yeah, so from the distance z should equal to I, z will be here, and then we're gonna further check the furthest. Yeah, so the furthest is gonna be still be here, and here, and it is this A. Yeah, it's not that. It is the rightmost. And then we're gonna check B, and we're gonna update the furthest. It is still here. Yeah, and then we're gonna check all other characters in between. This is why we're gonna use the same +1. And then we after updating all the furthest, now this furthest would be here, and we're gonna calculate the distance. It's gonna be the furthest minus this I +1. Yeah. Now I need to update the I. If I find a furthest, so this I gonna be equal to the furthest +1. Yeah. Finally, I need to return the result. I know it is a lot of a while loop, and maybe it is confusing. Let me just have a try to check if there's any mistakes. Yeah, let me just try to open another tab. Maybe it is faster. Yeah, as you can see, it works. I just opened another tab. Yeah, let me just try this tab if it works. Yeah, now the network, it seems okay. It works. So as you can see, the coding, it's really difficult to understand. Yeah. But definitely this is a great idea. As you can see, it works and it's pretty fast. Now let's analyze the time complexity first, and then further on optimize the code a little bit maybe. So from here we use a while loop, and for this while loop basically we're gonna check the furthest, and it's gonna become the furthest. And here another loop, it's gonna check furthermore. Maybe this furthest would be updated to another furthest value. And finally, we're gonna need this furthest. So actually from here to here, it is a O(n) squared time. Yeah, because for each of the letter, so for example, for A to A, and in between, we still need to check if it can expand it. And if it is expanded further, we still need to check in between. So actually, there are two while loops, and it is O(n) squared time. Yeah, maybe you know from A to A, maybe A is here, and in between we need to check the furthest position, and if we want to check the furthest position, we need to check one by one. So I think it is O(n) squared time. As you can see, we used the dictionary for the last value. So why not we just use the value directly? Maybe we don't need to use the list. Let's just use int. Yeah, I think integer is enough. So dc should be equal to I. Yeah, because definitely this is gonna be the last position if there is. Yeah. So from here, we don't need a -1 because definitely we got the last position. We don't need it. Yeah. This maybe looks even more clear. Yeah. So the first while loop is to check the first letter. For the first letter, what is the furthest position? We must get a range. The second while loop is from this range, can we extend the furthest? If we can, we're gonna have a record of the furthest, and we're gonna put it inside our result. And then the I pointer would be updated to furthest +1. Yeah. Now let me try to run it to check if it works. Yeah, as you can see, it works, and it seems it is much faster. Yeah, this is because we put an integer instead of a list. It will improve the time and space. Yeah. I think that's all for this problem. Thank you for watching. See you next time.